Alright, today we're going to continue talking about geometric sequences and series. Finding the sum of the first n terms of a geometric sequence. The first term a sub 1 is the beginning amount. The start with amount, the invested amount, so on and so forth. The common ratio is, if you're talking in these business things, it's going to be 100% plus the rate of increase per year. If R is not given, then you must calculate R. You take A2 divided by A1. The number of terms is n. And in the cases we're going to be working with today, it's the amount of time. And then you use this formula. If you're finding the nth term of a geometric sequence, all right, the beginning term is A sub 1. In these word problems we're talking about, that's the beginning amount, the start with amount, the invested amount. Your ratio, if you're talking increase, is 100 plus whatever you're increasing. If not given, you calculate it by dividing. And to find the nth term, you use this formula. Alright, so it says a union contract specifies that each worker will receive a 5% pay increase each year for the next 30 years. One worker is paid $20,000 the first year. What is this person's total lifetime salary over a 30-year period? Okay, so they're asking me to find the sum of the first, basically over his 30 years. Okay, so let's see. The first term is 20,000. Okay, so I found the first term. The common ratio is 100% plus the rate of increase. So we're going to have 105%. He's going to get paid not just his 100%, but he's going to get paid his 100% plus an extra 5%. That's what increasing your pay is. Okay, so my common ratio is going to be 1.05 if you write it as a decimal. Okay, and the number of terms is the amount of time. So T is 30. So if I plug this in, the sum of the first 30 salaries is going to be my 20,000 times 1 minus 1.05 to the 30th all over 1 minus 1.05. Alright, so when you type this in now, be careful. If you're going to do the top, and I like to do this a little bit at a time. I don't trust the calculators. So I'm going to do inside parentheses first and what's on the bottom. So the first thing we have to do is calculate 1.05 caret 30. And then I'm going to do 1 minus that. And you know what? Let me show you how to do this on the calculator without rounding. Sorry, I lost my calculator. Okay, so what you're going to do when you type this in is what I do is I type 1.05 caret 30 and I hit enter. Then I need 1 minus that, so I'm going to hit 1 minus, and I don't want to type all that. So right down here, this negative key, see how it's got answer in blue on it? So if I just hit second negative, it'll say my answer, and then I hit enter again. Then I'm going, so this is negative, oops, I can't write. Now I can't see what that was. Oh, it's right there in front of me. Okay, so I get inside there was negative 3.32. Come on. 321942375. Again, I'm nervous about rounding. 1 minus 1.05 on the bottom is negative 0.05. So now if I type all this in, I got 20,000 times negative 3.3219422375, enter, divided by negative 0.05, and you get the sum of the first 30 years will be 1328776.95. Okay, so that's going to be $1,328,776.95. That's going to be his total lifetime salary. And that's if you get $20,000 the first year with a 5% increase each year, which, I don't know. I ain't going to say it's normal because I haven't received a raise in forever, but. All right, so this one says, a job pays a salary of $27,000 the first year. During the next 5 years, the salary increases by 5% each year. What is the salary for the 6th year, and what is the total salary over the 6-year period? They're asking me to do two things. They want, first of all, just for the 6th year what he will make. So we're finding just the 6th term. And then they want me to figure out what he'll earn total over the 6 years. Okay? So my A sub 1 is 27,000. My common ratio, it says, is 100% plus your increase, and he's going to increase by 5%. That's 105%, which is 1.05 as a decimal. And N, they want the 6th term. So to find the 6th term, I say A sub 6 will be A sub 1, 27,000, times R, which is 1.05 to the N minus 1, so that's to the 5th. Remember, because it's your starting plus one less than you're looking for, common ratios. So I type 1.05 caret 5 first, enter, and then I hit times 27,000. And I get, on the 6th year, his salary will be $34,459.60. That's what he'll make on the 6th year. What will he make total, summing up all 6 years? Well, I use this formula, which will be 27,000. 1 minus 1.05 to the 6th, all over 1 minus 1.05. Okay? You can try typing all of that in at once. I don't trust my calculator. I don't trust either one of the two. 1 minus 1.05 caret 6 is that, times 27,000. Enter. 20 Samson. 27,000. Enter. Divided by, parentheses, 1 minus 1.05. And you get 1,83651.6459, which is $183,651.65 if I round to money. Okay, so on the 6th year, he'll make $34,000, and at the end of 6 years altogether, all 6 paychecks added up, or salaries added up, will be $183,000. Okay? Alright, so you try this one. Hit pause. Come back when you're ready. And hopefully you got 3. Alright, it says a small business owner made $60,000 the first year, so that's A sub 1. That he owned his store and made an additional 3%. So my rate would be 103%, which would be 1.03 as a decimal, over the previous year in each subsequent year. Find how much he made during his 4th year of business, and then find his total earnings during the first 4 years. Alright, so to find the 4th term, we use the general form. So A sub 4 equals A sub 1, which is 60,000, times 1.03 to the 3rd. And if you type that in, 60, I type it 1.03 caret 3, enter, times 60,000, enter. And I get 65563.62. Okay, and then to get the sum of the first 4 years, we use the S formula. S sub 4 will be A sub 1, 60,000, 1 minus 1.03 to the 4th over 1 minus 1.03. So if I type that in carefully, and maybe I should show you that. My calculator. So if I type this in very carefully without destroying anything or rounding anything. Oh crap, that's back on. So what I do is I type 1 minus 1.03 caret 4, enter. And then I hit times 60,000, enter. And then I hit divided by parentheses, 1 minus 1.03 parentheses, enter. And I get the 250, dang it, I forget I can't do that. I get the 251,017.62. Okay? Alright. Sorry, gotta go through it all again. Alright. Annuities. Alright, the compound interest formula, which means 1 times a year, is a PERT. Well, it's not a PERT, but AP 1 plus R to the T. It gives the future value A, in other words, the final amount, after T years, when a fixed amount of money, your principal, is deposited in an account that pays an annual interest rate R in decimal form, compounded once a year. However, money is often invested in small amounts at periodic intervals. For example, to save for retirement, you might decide to place $1,000 into an individual retirement account. At the end of each year until you retire, an annuity is a sequence of equal payments made at equal time periods. An IRA is an example of annuity. So, we have this big O formula when you're compounding n times a year. If you're only compounding once a year, you can use this one. But if you're compounding n times a year, you have to use this formula. P is the deposit made at the end of each compounding period. So it's your payment that you're going to make instead of your principal. R is your percent of annual interest compounded. N is the number of times a year they're going to compound it. And A is the money that you're going to have at the end of your savings. Alright, so it says at age 25, to save for retirement, you decide to deposit $200 at the end of each month into an IRA that pays 7.5% compounded monthly. How much will you have from the IRA when you retire at age 65? Alright, so what's going to happen is we need an A, we need a P, we need an R, we need an N, and we need a T. How much will you have when you retire? That's the question mark. So I don't know the final amount. What are your payments that you're going to make at the end of each compounding, which is $200. Your rate is 0.075. Your N is, they're compounding it monthly, so N is 12. And your time, you're gonna do this from age 25 to 65, which is a total of 50 years. Okay? So if I plug everything in, my amount will be 200, bracket, parentheses, 1 plus 0.075 over 12 to the NT, so 12 times 50, minus 1, all over 0.075 over 12. Okay? So now we've got a bit of a mess. And again, I'm going to show you how I type this. Let me get my calculator up. So, figure all that. I'm going to work from the inside out. I'm going to start on the inside parentheses. So I'm going to do 1 plus 0.075 divided by 12. Enter. And then I have to raise that. So caret, parentheses, 12 times 50, enter, and I get that. Then I'm going to minus 1, and I get that. Then I'm going to multiply by 200, and I get that. And then I'm going to divide by parentheses 0.075 divided by 12, and enter, and I get that big number. 1312887.645. Okay, so the amount will be 1312887.645, would round it, if you're talking money, to 65 cents. Okay, so B says find the interest. The interest is going to be the value of the investment minus the total deposits. So the value of my total investment is $1,312,887.65. My total deposits are $200 every month for 50 years. So you're doing 200 12 times a year for 50 years. So 200 times 12, 200 times 12 times 50, and you get 120,000. So you paid 120,000. They gave you $1,000,003. The difference is 1312887.65 minus 12123 4. Right? 4 zeros. And you get 1192887.65. Oops. So your interest is $1,192,887.65. Pretty good, eh? Alright. So, you hit pause, try this one, come back when you're ready. And hopefully you got 2. Alright, so it says to save for retirement, you decide to deposit $2,000 into an IRA at the end of each year for the next 30 years. If the interest rate is 6% per year compounded annually, find the value of the IRA after 30 years. It's compounded annually, so I really don't need this big long one. I can use that shorter one, but the long one always works. Alright, so A would be, I don't know. What do we need? P, R, N, and T. My payment that I'm going to make is $2,000. My interest rate is 0.06. It's compounded annually, so N is 1. And my time is 30 years. So if I plug that in, I get A equals 2,000, bracket, parentheses, 1 plus 0.06 over 1 to the 1 times 30 minus 1 all over 0.06 over 1. Okay, so these I can just rewrite as 0.06s because over 1 is silly. So now when I type this in, I'm going to type 1 plus 0.06, enter, caret 30, enter, minus 1, enter, times 2,000, enter, divided by 0.06, enter, and you get 158,116.3724. So that will give me 158,116.3724. If I round, it's just going to be 0.37. Yeah? And there's your answer. Oh, they said round to the nearest dollar. Okay, so some homework help, some problems that are going to be like on your homework. It says, use the formula for the general term, the nth term of a geometric sequence to solve exercises 65 to 68. It says in 65-66, suppose you save $1 on the first day of a month, $2 the second day, $4 the third day, and so on. So you're doubling every day. That is, each day you save twice as much as you did before. 66 says, what will you put aside for savings on the 30th day of the month? So they want the 30th term, which will be the first term times my common ratio, which is doubling, right, to the 29th. So if I type that in, I do 2 caret 29, you get 5, 3, 6, 8, 7, 0, 9, 1, 2. Wow, on the 30th day, you're going to have to save, you're going to have to put aside $536,870,912. That's crazy. Okay. 68 says you're offered a job that pays $30,000 for the first year. so that would be A sub 1, with an annual increase of 5%, so that would be 1.05. Blah, blah, blah. What can you expect to earn in your 6th year on the job? You're trying to find the 6th term. So you would use our big ugly formula that I did not put on here, and I do not have memorized. But you'd plug it into the A equals P bracket parentheses, what was it, 1 minus R over N to the NT minus 1 all over 1 R over N, I do believe. You plug them in and solve it from there. Alright, you saved $1 the first day, $2 the second, same thing. Why are they doing that? Oh, because now you're using the sum one. Okay, what will your total savings be for the first 30 days? So you're using that sum of the first 30 days formula. 74, you're investigating 2 employment opportunities. Company A offers $30,000 the first year, and during the next 4 years you will get a 6%. So for them, your A sub 1 would be $30,000, and your rate would be 1.06. Company B, your initial term would be $32,000, and your rate would be 1.03. And it says, which company offers the better total salary for a 5-year contract? By how much? So on each of these, you're finding T for time is 5. Well, plug them in and get your total here, get your total here, and the highest one wins. Okay? So 76, it says a pendulum swings through an arc of 16 inches. On each successive swing, the length of the arc is 96% of the previous length. So your first swing, your second swing is the 0.96 of 16, right? Your third swing is going to be 2 copies of the common ratio times the initial term. Your fourth swing is going to be 3 copies of the common ratio times the initial. So if I want the 10th swing, it's going to be the common ratio, 9 copies of that times 16, and then you type that in, 0.96 caret 9, enter, times 16, and you would get the 10th term is 11.0805439.3. Yeah? Oh, my bad. No. It didn't say on the 10th swing what is it swinging. After 10 swings. So we actually need there's the same thing, your common ratio, but you need the sum formula. The sum of the first 10 days or 10 swings. All right, 78, to save money for a sabbatical to earn a master's degree, you deposit $2,500 at the end of each year in annuity. So there your payment is $2,500. Your rate is 0.0625. You're compounding annually. And for A, they want time to be 5. And then find the interest, just like that one we did, the example we did in the presentation. Okay, this one's another one where you're paying into an IRA. So it's going to be just like the ones we did in class. Okay, 82, to offer scholarship funds to children of employees, a company invests $15,000 at the end of every 3 months. So again, you're using the payment one, okay, the big annuity one. Your P would be $15,000 at the end of every 3 months. So your N is quarterly. Your rate is 0.09. And for A, they want your time to be 10. All right, plug them in, get your answer, and then for B, subtract and find your interest. Okay. Again, for 85, a new factory in a small town has an annual payroll of $6 million. It's expected that 60% of this money will be spent in the town by factory personnel. The people in the town who receive this money are expected to spend 60% of what they receive in the town, and so on. What is the total of all this spending called the total economic impact of the factory on the town each year? So you're starting off with 6 million, right? And you're going to spend 60% of that. So you find, what do they want? What is the total of all the spending? Oh, so you're finding again the sum. And then how much additional spending will be generated by a 10 billion tax rebate if 60% of all income is spent? How much additional spending will be? Oh, so you up this by 10 million. Okay, so this one they just want you to calculate and compare which one is best. Alright, so what do tax rebate, annuity, and salaries have to do with geometric sequences and series? Well, because when you do tax rebates, annuities, and salaries, it's all a way of basically adding up money that follows a geometric pattern. Most of these things, they give you an increase per year or something like that. It's happening every year, so it's a pattern. And that's why it follows the geometric series. Alright, so we are at homework, which means we are done. Happy homeworking, and I will see you next time.